Hello everyone, today is December 6th, 2025, and we're going to look at this LeetCode question number 380. Insert, delete, get random in all of one time there. So this question is basically asks us to implement a data structure. It has like constant insert time, remove time, and get random there. So basically like a set. This is called randomized set. In a set, you can already like insert and remove in a one, but you cannot probably get random there. So we need to add like a one more feature to the set interface there. So to implement that, I think we need to use some combined data structure instead of just a single set. And the data structure we're going to use is probably a list. So let's try to initialize the stuff first there. So when we initialize the data structure, internally we're gonna host a variable called values and let it be a dictionary. And then we can host like a value to position mapping. And this should be a dictionary instead. And the values, we just call it like a list instead. So basically, like the first variable is gonna be used to implement the GetRandom function. So because it's pretty easy to randomly pick a variable from a list, and the other variable like value to position, this is used to store the value mapping to its index there. So we'll keep going with the implementation. You'll see how this is used. So for insert, it's gonna return a Boolean. So if the value is already in like a self.out, then we need to return a Boolean. Let's look at a question, see if it asks us to return true or false. So insert into the set, if not present, return true. If it's already there, just return false. So we can just return false here. And then if we can get to here, we would do the implementation of insertion. So first of all, add it to the append this variable to the end of the list. And then self.route to position equal to, this is a dictionary, so the key will be the value being inserted, and the index would be, so right now the position of this is 1. So I think would be like the length of the list rows and -1. Yep, so we inserted to the value the vowels here. Now the length of vowels becomes 1, and its index is 0, so it's always like the length of the element -1. Okay, and remove. So remove is a little bit tricky. Let's implement the GetRandom first, because this is so like a simple. So there's a function called random choice, and this is just a value self.values. Yeah, self.values, and just pick one from the list here. And this is just a GetRandom, it doesn't need to like remove it. So now to remove is probably the most complicated one there. So let's see how we can implement that. So let's get the index from of the value that being removed first. So value to position mapping, and using val as the lookup key to find out the index. And then the last element of the vals. So this is looking at the list and look at the last element. So we can get this value out. And then we need to kind of, because the val with its index, this is the number that being like a delete from the data structure. So, and the last element is not gonna be deleted. It is pawned there. So we're gonna do a swap here. So basically like so let's see how we can do the swap. So let's swap the vals first. So the index, this is the original position index of the value being deleted, should equal to last. And then we update the position index. So val to position, basically last. And right now we put this last into index. Then the end of the end of the both the list and the dictionary can be removed. So by self.vals, you can just pop it. So we shrink the list by 1 by removing the end of the list. And for the dictionary, we can just delete the key. So this is value to post, and the key is val. So there's no more val here, and last also got its new position. So I think I can think of a tricky part is like, what if the value being deleted is equal to the last element there? So let's see if that still works there. So if that's the case, IDS will be last, and then you update last value, or you get the last value and then you update it. So basically you are not swapping here. It's basically the last position swap to itself, then it still keeps in the last. And then this would delete this value and its position from the two internal data structures. So I think that should work. Let's try to test it. So the small test. Okay, there's some error here. Let's see what's going on. Remove self val to post. Self val to post equal to remove object remove. Key error. Okay. So it doesn't have the key here. Let's look at the input. So you initialize the set and you insert 1 and you try to remove 2. So basically you cannot remove things that's not in the in the set there. So like if not in, oh I see. So this would also need to return a Boolean. So in the question here, it will return you will remove if present, then you will return true. So if it's not present, you will return false there. So if while is not in self dot while to pose, if it's not in here, then you just return false. And otherwise you keep going and at the end return true. Yep, let's test it again. Okay. So while to pose is not defined, so we miss the self here. Yep, it passed the test now, and also the big test. Yep, looks like it's good. So if it's like 21%, it's kind of slow, but it's okay. So let's look at the time and space complexity. So basically, yeah, it's basically like pretty much the question is out there. Insertion is all one. So appending the element to the list, it's all one. And this is like updating the dictionary is also one. And remove, basically it's just like one swap and then one delete. So these are also like a constant time. It's independent of the length of the list and also the number of keys of the dictionary. And GetRandom is also apparently a one. So yeah, that's our implementation using a combined two internal data structure to implement this randomized set so that we can achieve like a O1 for insert, remove, and GetRandom. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.